Hi everyone. I thought I would take just a couple of minutes and do a few examples off the fraction practice packet that you've been working on. There are some tricky ones that come up once we start getting into variables, and I know I already put together another video to kind of remind you how fraction operations work, but that does sometimes look a little bit different when you're working in variable land. So let's take a few minutes. I'm going to pull mostly from the section titled Part 2 because that's when the variables come in. I think I'll start with number 18. And so 18 says x over y plus y over x. So we know that to add fractions, we need a common denominator. And we don't know what numbers y and x represent, so it's kind of hard to come up with what that common denominator should be. But you can always come up with a common denominator just by multiplying the two numbers by each other. So for example, if this number down here on the bottom was a 3 and this number was a 5, a common denominator would be 15. And even if that's not the smallest denominator that would work, it is a denominator that would work. So what I'm going to do is I'm going to multiply on the left here by an x on top and bottom. And I'm going to multiply by a y on top and bottom over here. So keep in mind I'm allowed to do that, first of all, because multiplying by x over x or y over y is really just like multiplying by a 1. And then look at what's going to happen here. My common denominator is going to end up just being xy. So I could rewrite this problem now as x times x over here is x squared over xy plus y squared over xy. And then because they have a common denominator now, I can just add together the top. So I can say x squared plus y squared. And that whole thing would be over xy. And that would just be my final answer here. So a lot of these problems you're going to look at and think like, my gosh, why is she having me do this? What's the point of that? When we get into the next lesson, I think you'll see how a lot of these structures are helpful. I wrote these problems based on the things I'm going to be asking you to do in the next lesson with some trigonometry identities. So this will all come back to haunt you, I promise. Let's take a look now at maybe, which other one looks hard? Let's maybe look at 23. So 23 says x over y times x plus x divided by x over y. Okay, so for this one, I'm going to kind of deal with this in two chunks. I'm going to figure out how to simplify this, and I'm going to figure out how to simplify this. And this addition is going to be kind of the last thing that I do, because I have to follow order of operations. So all of this multiplying and dividing has to come first. So with this first one here, remember this x is really like an x over 1, and then I'm just multiplying top by top and bottom by bottom. So this whole thing can just be written as an x squared over y. Now the second one's a little bit trickier, and I might work through this off to the side and then translate my answer down below. When you're dividing by a fraction, remember we're really multiplying by a reciprocal. So this really turns into like x times, and then the reciprocal of that would be y over x. And this x, of course, can be thought of as x over 1. So this really turns into xy over x on the bottom. And then we have addition. Okay. Now I need a common denominator down here, just like I needed a common denominator here. So I'm gonna employ the same tactic here. I'm gonna multiply by an x over on this side, and I'm gonna multiply by a y, over on this side, and that leaves me with an x cubed over xy plus, let's see, here I would end up with an x, and a y times y gives me a y squared. So xy squared over xy. And then I can put those things together. And on the top, I would say I have x cubed plus xy squared see if I can shift this all up just a little bit. There we go. And that would be over xy as a denominator. So that's a really ugly one, but that's how that one would end. X cubed plus xy squared over xy. All right, let's keep going. Let's see. I might actually just jump to a new page here. All right, so that was 23 that we just talked about. Let's maybe look at 26. (26) says x cubed over y squared minus 1. I like working with ones. I need a common denominator for this one, but my common denominator should just be a y squared, right? I just want to get it so that it's something over y squared. The reason I said I like working with ones is I can write 1 as anything over itself. So if I just make this y squared over y squared, I've got my common denominator now. So on the top now, this would just say x cubed minus y squared. And on the bottom, I would just have that y squared. And we'd leave it alone. All right, I know I said I was mostly going to stick to ones from part 2, but maybe let's pull in one from part 3. So in part 3, you were having to do some crazy substitutions for some letters. And again, there's a purpose for that. I'm just going to grab one here. Let's maybe look at... How about 31? So 31, and I'm not going to rewrite all of this on here, so you may want to look back at your packet to see what I'm referring to. But 31 tells you to do n squared minus p squared. But then they tell you that n is really equal to 1 over y. And then they tell you that p is really equal to x over y. And they're both being squared. So when you square a fraction, really you're just squaring the top and squaring the bottom. So on the left here, 1 squared is 1, and y squared is y squared. On the right, I'm going to end up with an x squared on the top and a y squared on the bottom. And I like this because I have y squareds on the bottom for both. So that's going to leave me with 1 minus x squared on the top over y squared on the bottom. And leave it alone. So like I said, everything that we just talked about is going to come up in that next lesson that we do. All of these things, even the substitution piece, you're gonna look back at this assignment after doing the next couple of lessons and totally understand what I was trying to make you do, even though you feel like I'm making you crazy right now. But hopefully these problems aren't too difficult for you. Hopefully your fraction skills are kind of up to snuff, but we will gladly go over anything in class that you're struggling with. All right? Have a great day.